Hey kids, so today's video is about derivation of Newton's second law of motion, which exactly means is we have to derive F is equal to ma, father equals to ma, right? Okay, so let's derive this. So what exactly is Newton's second law of motion? It just states that if there is an object, suppose it's having a mass m and initial velocity u, okay, and we apply a force on that object, mass remains the same m, but its velocity changes to v. Okay, so the change in momentum, okay, what would be the initial momentum of this body? You know what momentum is? Mass into velocity, right? So initial momentum will be mass into initial velocity, and final momentum will be mass into final velocity. Okay, what do you mean by rate of change of momentum? Okay, whenever we are telling rate, okay, it's divided by time. Okay, rate means per unit time. Okay, change of momentum means final momentum minus initial momentum. Okay, so rate of change of momentum equals to final momentum, that is mv of that body, initial momentum, that is mu upon t. So rate of change of momentum, m common, v minus u upon t. And what is v minus u upon t? It's rate of change of velocity, right? Rate of means divided by t, and change of velocity is final velocity minus initial velocity, and we know that rate of change of velocity is nothing but acceleration, right? Okay, what is the formula of acceleration? V minus u upon t, and the same thing we have used here. So rate of change of momentum equals to mass into acceleration. Okay, so let this be 1. So according to Newton's second law, okay, according to Newton's second law, the force applied is directly proportional to rate of change of momentum. So force applied is directly proportional to ma from 1, right? Okay, so whenever we are using equal to sign after proportional, we need to multiply it by a constant. There is some constant, right, involved in it. So k is what? K is constant of proportionality, F equals to kma. Okay, and on the basis of many observations, okay, we come to know that the value of k, that constant, is always equals to 1. If that constant is always equals to 1, what does this imply? F equals to 1 into ma, means F equals to ma. Okay, and this is the derivation of Newton's second law of motion. It's easy, right? Okay, so how did we start? So we start with a object whose mass is m, initial velocity u, we applied a force. Because of the force, initial velocity u increased to v, okay, or decreased to v, whatever it might be, it changes. Okay, so what was initial momentum? Mass into initial velocity. What was final momentum? Mass into final velocity. What do you mean by rate of change of momentum? Rate of means divided by time, okay, per unit time. Change of momentum means final momentum minus initial momentum. So rate of change of momentum is, what was final momentum? mv minus initial momentum mu upon t, m common, v minus u upon t. What do you mean by v minus u upon t? Acceleration, rate of change of velocity. So rate of change of momentum equals to ma, keep that 1 aside, and then according to second law, rate of change of momentum is directly proportional to the force applied. So F directly proportional to ma, k is constant. By removing this proportionality sign, F is equal to kma, k always equals to 1, therefore F equals to ma. Okay, and this rate of change of momentum happens in the direction of force. Okay, so remember that. Do your best for your exams. Bye bye.